40. Well, 5 times 2 gives 10. Times 2 again gives 20. Times 2 again gives 40. They're all prime. Yes. All right. So there is a way of getting this list of prime numbers using something called a prime factor tree. So a prime factor tree helps us get that answer we got before. So the product of prime factors, product means multiply in maths if you're not sure what product means. Product of prime factors, so for example, 40 as a product of its prime factors is 5 times 2 times 2 times 2. All prime numbers multiplied to give 40. They are its product of prime factors. So each number has a kind of unique one. So let's do an example. Let's do 420. And let's see, can we make this a unique product of prime factors? So it's unique kind of pattern that multiplies to give it. A bit tricky just off the bat thinking about what numbers would multiply. Maybe some of us can do it. What numbers would multiply all prime numbers to give 420? But we can definitely think of two numbers, not prime, that multiply to give 420. Just any two numbers that multiply to give 420. Max? Any two, yeah. Nilu? 210 and 2. Not where I would have gone, but I'll go with it. 210 multiplied by 2 does give 420, yeah? Correct. So what I've done there is I've split it up into two things that multiply to give the one above. But I can also split up 210, can't I? Ren?
I was going to say 4, 6 times 7 times 10.
Oh, you're giving an answer, yeah. But I just want 21, or 210. Here, I'll help it. 210 is 21 times 10. Yeah? Okay, I'll split that up. Well, I can split 21 up again, can't I? 3 times 7. 10, I can also split up. What's 10? 2 times 5. I'm going to stop here. Why would I stop here? Well, I could keep going if I wanted to, but as soon as I get prime numbers, I'm looking for prime factors. These are all prime factors. I could keep going, but what's the factors of 3? Well, 3 and 1. Or then I get what's the factors of 3? 3 and 1. And you see, it would just go in an infinite loop of going 3 and 1 forever. So instead, I go, right, these are the prime numbers that multiply to give that. 3, 7, 2, 5, and 2. So if I was listing out, and the answer is, 420, not 210. 420 can be formed by multiplying these numbers together. Are you convinced? Maybe. So how would I list them? Usually I go smallest to biggest or biggest to smallest. Let's go smallest first. 2 times 2 times the 3 times the 5 times the 7. Okay, well let's check. Does that work? What's 2 times 2? 4. Times 3? 12 times 6. Or 12 times 5? 60. 60 times 7. 60 times 7. Oh, well, 6 times 7 is 42, and the 0 would be 420. It does work. So this is the product of prime factors. How do we get it? By using prime factor tree. How are these two numbers formed? They multiply to give the number above. 21 times 10 gives 210. Now, normally I don't put in the multiplication symbol, but hopefully you can see that. Make sure you have an example of prime factor tree in your book. I'm going to give you, some prime factors to draw. So